Hi, Assalamualaikum. My name is Hafizulhelmi bin Khairudin, and today I would like to present about real, reactive, and apparent power in a single-phase circuit. Real, reactive, and apparent power. In this section, I would like to describe about the relationship among real, reactive, and apparent power in a single-phase AC circuit. From the figure show, the power supply to the direct current load is simply the product of the voltage across the load and the current flowing through it. In sinusoidal AC circuit is more complex. This is because there can be a phase difference between the AC voltage and the AC current supply to the load. The instantaneous power supply to an AC load will still be the product of the instantaneous voltage and the instantaneous current. The average power supply to the load will be affected by the phase angle between the voltage and the current. From figure shown, a single phase voltage source supplying power to a single phase load with impedance Z is equal to Z angle theta ohm. When the load is inductive, the impedance angle theta of the load will be positive. Then the current will lag the voltage by theta degrees. The voltage applied to this load is where V is the RMS value of the voltage applied to the load. The formula is Vt equal square root V 2V cos omega t. Then the resulting current flow is where I is the RMS value of the current flowing through the load. The formula is It is equal to square root 2I cos omega t minus theta. The instantaneous power supplied to this load at any time, which is t. The formula is Pt equal Vt It equal to 2Vi cos omega t minus theta. For inductive load, the impedance angle is positive and the current waveform lags the voltage waveform by theta degrees. When applied trigonometry identities to equation, it can be manipulated into an expression of the form. The formula is Pt equal Vi cos theta 1 plus cos 2 omega t plus Vi sin theta sin 2 omega t. Real power. The instantaneous power expression is always positive, but it produces pulses of power instead of a constant value. This is the average value of the term, which is the average or real power or P supplied to the load. For the unit of the real power are watts, which is W, where 1 watt is equal to 1 volt times 1 ampere. So for the formula of real power is P is equal to Vi cos theta. Next is reactive power. Reactive power represents the energy that is first stored and then released in the magnetic field of an inductor or in the electric field of a capacitor. The reactive power of a load is given by the formula where its theta is the impedance angle of the load. Q is positive for inductive load and negative for capacitive load. For the unit of reactive power are volt amperes reactive, which is a VAR, where 1 VAR is equal to 1 volt times 1 A. For the formula of reactive power is Q is equal to Vi sin theta. Lastly, for apparent power. The apparent power or S supplied to a load is defined as the product of the voltage across the load and the current through the load. This is the power that appears to be supplied to the load if the phase angle differences between voltage and current are ignored. For the unit of apparent power are volt ampere, VA, where 1 volt ampere is equal to 1 volt times 1 A. So for the unit of apparent power is S is equal to Vi. So that's all from me. Thank you.